Welcome back to Chapter 10. This is the beginning of Unit 3 of Statistics. In this unit, we're going to start out with looking at randomness and simulations, and we'll also get into some other data collection. But this chapter is on understanding randomness. Our this chapter, this whole unit, won't have as much math in it as some of the previous topics. Like we won't be dealing with equations and stuff so much. We will still be using a little bit of math here and there, but not like what we were doing. So that may or may not be a good thing for you. Depends on who you are. But there's a lot of concepts, and we will be doing some procedural stuff as well, just not math. So our learning targets: determine whether outcomes are random events, plan or perform simulations involving random numbers, identify incorrect conclusions and bad simulations. So, the first thing we need to talk about is random. Now, random gets a bit of a bad name in society. Random does not mean haphazard. It does not mean unexpected. What random is it usually has some sort of a structure. Each individual event, each individual outcome, we don't necessarily know, but over the long run, the outcomes are fairly consistent. So an example of this, rolling dice. When I roll dice, it's a random event. I don't know what I am going to get on any given roll, but I know that I have about 1/6 of a chance of getting a 1, a 2, a 3, a 4, a 5, or a 6. I'm assuming I'm using just a regular cubic D6 dice here, so some of you guys can just calm yourselves. But we know in the long run what some of this stuff is going to be. That is random. Um, a spinner, spinning a spinner, depending on how many spaces there are and what the area is for each space, we know what the possible outcomes are, and we can get about the probability of each outcome. Drawing cards out of a deck is random. Flipping a coin is random, heads or tails. I don't know what this coin flip's going to be, but about 50% of the time, it's going to be heads. Um, Pulling a card from a deck, as I mentioned. I don't know what the cards can be, but about 1/4 of the time, it's going to be a heart. And so that is the structure that these random events have. Again, each individual outcome, we don't know what it's going to be. So I don't know what the next card is going to be, but I could probably give you some information about what it could be, and that's based on long run um, data. Um, this comic was in there, and it's pretty good. I actually have another comic. It's on the wall of my classroom, and I wish I had it. It's an old, I want to say it's a foxtrot, and it's about someone trying to make a truly random numbers. But this one, guy comes in, hey, I'd like to buy a lotto ticket with numbers 1, 2, 3, 4, and 5, please. It's like, you're not going to win. That's not random. It's like, well, those random numbers, 1, 2, 3, 4, 5, has the exact same probability as coming up as any other set of 5 numbers. So just because they're together doesn't mean they won't come up. They haven't come up yet in the history of the lotto, as far as I know, but that's true with most of the number combinations out there as well. Eventually, once the lotto plays enough, 1, 2, 3, 4, 5 will come up. Again, the probability of that is going to be the exact same as any other 5 numbers that you could pick. So um, the numbers that you pick aren't actually that important. How do we generate random numbers? There are numerous ways of generating random numbers. You could use technology. Um, the StatCrunch software can generate random numbers, I'm sure. Your calculators can generate random numbers. Now, those aren't actually random because technology can't generate anything random. That's not how the programming works. Um, a fun trick to do in class is to have everyone has like my calculators, and if I reset my calculators right before class and have everyone generate a random number, everyone will randomly generate the exact same number. Because what the calculators do is it has a list of random numbers, and when you generate or when I you reset it, it sets it back at the beginning, and then um, everyone hits that same random number. That's not actually random. Now, it behaves like a random number, so it is possible to treat them like a random number. But if I had everybody doing a simulation, like we'll talk about later, everyone would get the exact same results, and that would not be particularly good. Um, you can have you can set them to different places, so it'll start off in different places of the list. Um, and so they behave randomly. It's called pseudo-random. Computer programming it does the same thing. So it's not actually random because a computer can't actually generate that. Another way of generating random numbers is by using a random number table. There's one in the back of the book. You get one on the AP test. No, you don't get one on the AP test. But if you do have a question with one, it gives you a chunk of a table. Um, you can find them online. There's books of them. They used to be way more common before we had computers and stuff. But what a table of random numbers looks like is kind of like this. This is only the top little bit of it. I wanted to be able to blow it up so you guys could actually read it. And this is right from the back of your book. It's right there. You can get there using the e-text as well. If you don't have your book, you just go to the e-text and go to the appendices with the tables, and it's in the tables appendix, obviously. And you just scroll through until you get to the one that's random digits. Um, and so we have most tables of random digits look kind of like this. The rows are numbered because I could have you do something and choosing random numbers starting at row 6. And everybody's going to get about the same results because you're going to be using the exact same random numbers. That's useful in class because I can see if you're doing the process right. Um, Not so useful necessarily in the world because you don't want everyone to be getting the exact same things necessarily because that kind of defeats the purpose of a simulation. Um, but they are numbered so that you can start. They're broken up into groups of 5, and that is purely for the ease of reading. If it was one long string of numbers, that gets kind of challenging to go through. Um, the breaks have no purposes though, other than just to group them up. So if you were looking for 2-digit numbers, like we needed to find a bunch of 2-digit numbers, and starting at row 1, we would have 96, 29, 90, 71, 96, 98, 64, 22, 06, etc. When we get to the end of the row, we just move right down to the beginning of the next row. And so even if it's mid-number, we can move. So if, let's say, we ended up with 94, 16, 87, we just go right down to that row. Um, and so that's how you can get random numbers, and you can use it for any length of digits you want. A lot of times we'll use 1 digit or 2 digits, sometimes 3 digits. We don't usually get things above 3 digits. It is possible. Sometimes you would use things where you would skip things. For instance, if I wanted to generate, like this is a simulation, we'll get there in just a second, but I was drawing cards out of a deck of cards, and I wanted to know the suits that I was getting. Well, we have hearts, spades, diamonds, and clubs. Each of them is 1/4. So we could use 1, 2, 3, 4. Well, if we do that, we're going to have to skip a lot. So let's use 8 cards. So hearts would be a 1 or a 2. Spades would be a 3 or a 4. Diamonds would be a 5 or a 6. And clubs would be a 7 or an 8. And then 9 and 0, I don't know what happened with that line there, we just skip those. So if we wanted to start on, say, line 5, we have a 4, so that would be a spade, and then a 7 is a club, and then a 3 is a spade, a 5 is a diamond, and a 2 is a heart. So in a 5-card deck, we had a spade, club, spade, diamond, heart. And then the next one, we had a spade, heart, 8 is a club, 5 is a diamond, 3 is a spade. In the next one, we had a 4 is a spade, and then a heart, and we'd skip that one, skip that one. 3 was a spade, skip that one. 7 was a club, and 5 was a diamond. So even though we went out to here, we still had 5 cards. We just had to skip a few of them because those weren't numbers that we were looking for. So you can do things even if you don't have the full values there. So simulations. Simulations are ways that we can run experiments or something like that to see if the results make sense or if the results are unusual. Um, Typically, on the very first day of class, I have you guys run a simulation. I didn't this year because this year was kind of weird, but generally speaking, day 1 of class, we run a simulation. What is a simulation? Simulation is we have a company that has 30 employees, 20 of them are men, 10 of them are women, and they have to fire 10 employees, and they end up firing 5 men and 5 women. Well, the women that got fired were a little bit upset at this because they think that they were being discriminated against because an equal number of men and women were fired even though there were twice as many men at the company. And so the question is do they have a case? And so what the simulation was is I didn't even use a random number table. This one would be a little bit difficult for that because you can't fire the same person multiple times. We can't run an experiment on this because we can't go to a whole bunch of companies that have 30 employees with 20 men and 10 women and randomly fire 10 of them. That doesn't work out so well. People get upset. I mean, you'd have to find these companies that work like that anyway. And so what could we do? Well, I gave each of the students in the class a company with 20 men and 10 women, and they had to fire 10 randomly. How did that happen? Well, each company was a baggie, and in that baggie, I had 30 beads. 20 of them were black, 10 of them were red. They had to reach inside, and just randomly pick out 10 beads and see how many women did they fire. And then we looked to count how many people fired at least 5 women. It usually came out to be about 27%-ish of the students randomly fired about 5 or at least 5 women. So some fired 6. I think one person over many years may have fired 7. But that's just random. And so the intent was for them to get into a fight over whether or not it was random or if the women were being targeted with discrimination. The first day of school, no one was brave enough to actually start that fight. They all just kind of agreed. It's like, oh, so it's like 27% did it, so I guess that works out. That could have been random, and so there was no case for discrimination. What is the answer? I don't know. Like, that's not the point. The point is, with a simulation, we were able to simulate the situation where we were firing these 10 employees. We did it a bunch of times and we found what's the probability of firing at least 5 women. And the probability was actually, I mean, 27% is a good enough probability that they probably didn't have a case. Um, but that's one way to use a simulation. Another way, and this will involve using random numbers. Um, so, Mr. Swanson, that's me. I throw axes. I teach throwing axes, and I hit the bullseye about 70% of the time. So the question is I'm in a competition with someone. May or may not be a student. I don't know. We'll call him Brody. So I'm in this competition, so I'm way more focused. And I throw 20 axes and hit at 18 bullseyes. Am I on fire? Or en fuego, if you will. So is hitting 18 unusual if I normally only hit 70% of the time? Well, let's see. We can do a simulation. So 70%, we can do that with just 10 digits, right? Let's say a 1 through 7 is a bullseye. So that would be 70% of the digits, which means an 8, 9, or 0 is a not bullseye. We're going to throw 20 axes and see how many bullseyes I get. And then we'll throw 20 more and see how many bullseyes I get. And so the question is, out of the 20, do I have greater than or equal to 18 or less than 18? So we'll pull up our random numbers and we'll start at, we'll just start at list 1 since we only have 8 rows here. So 8, 9, or 0 are not bullseyes. So in the first row, I miss, 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 miss. So there's 5 in each, so I need 4 groups. Miss, miss, miss. So that I didn't hit at least 18. I missed a whole bunch. So we'd have a tally there. My next set of 20 throws. I missed there, 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 and none in that one. So let's see, we had one set of 20, another set of 20. And so 1, 2, 3, 4, 5, so I only hit 15 of them, so that was less than 18. So there's a tally there. And then next set, 8, 8, 9, 8, 9, 0. So I missed less, or I hit less than 18 bullseyes there. Next one, 8, 8, I can only miss 2. Nope, missed that one, so it's going to be less than 18 again. So there's my 2, 3, nope, it'll be less than 18. And so we can do this a whole bunch of times. Like so far we have 5 trials. In most of the assignments, it'll tell you to do 20 trials. 20 trials is still a super low number of trials. But we will continue for that. So it's 2, 2, oh, nope. I got less than 18 again. Oh, got less than 18 again. 8 to 9, 9, less than 18 again. So that one went to here. 2, 6, there's 1, 2. Hey, I hit 18 bullseyes, so I got one. It took me to the 9th trial, but I did it. Oh, hey, there's another one. 10th trial, I got another. And then we could keep doing that. I'll stop at 10 trials so that you guys don't have to keep watching this. And so out of my 10 trials, I hit 2 out of the 10. So I'm hitting bullseyes. I'm hitting 18 out of 20, 20% of the time. So is that, am I on fire? Is that like out of the usual? Did I step it up in my competition against Mr. Brody? Or is that just kind of normal, just kind of within that variability? Well, 20%, that's, that's where that discussion comes in. Later on, we'll find um, better ways of kind of getting that threshold of what's going to be considered really like out of that variability range. But right now, we do it. It's like comes out to 20%. I'm hitting at least 18 bullseyes. That's pretty good. That's about 1 out of every 5 times that I throw 20, I'm going to get at least 18 bullseyes. Um, so that's how we can do simulations. These random number tables, by the way, like the numbers are randomly generated. Each of the digits should be about the same, like on there, the same proportion of times. Um, and they're just randomly spread around. How is it actually calculated? Well, it depends on the table. Some of them are really sophisticated as far as the layout. Some of them are not, but they're all about the same. So this was kind of the extent of chapter 10. Make sure you read the chapter. This one's a pretty short one. It shouldn't take very long, but they do show how to find random digits in the calculator and on technology, and they give some more examples of this stuff. So make sure you read it. But other than that, I will see you in class. But until then, keep working problems, keep asking questions, and as always, happy mathing.